Hello folks, we are back with the video video of the problem number 26. Actually so happened that the video was already taken but it was not giving clarity. I will just check if the clarity is all right. Yeah, so because it was not clear, I am again we'll just go over the problem because it was already short, and because of lack of clarity I have to just go over the problem once again. Problem number 26 says that show that the semi-vertical angle of the right circular cone of a given surface area and maximum volume is sine inverse of 1 over 3. So we do exactly like what we did in the previous question. We take this cone with the height h, radius r, slant height L, and alpha as a semi-vertical angle. But this problem is little more complicated. Why it is complicated? Whenever you're given surface area, the problem is a bit of work. You have to do a lot of steps and then arrive to the maximum volume. They have asked us to calculate the maximum volume, and not only that, they have asked us to do something about the semi-vertical angle. So it calls for work. So we first, as usual, we just write the definition there, and then we just popularize the terms that we use there, and then we write that we know that the surface area is, because surface area is given to us, so we have to start from the surface area. We know that volume is going to be pi over 3 r squared h, where there is going to be two variables which we have to reduce to one. That's our task always. So what we are doing is we're starting with our surface area. Surface area S is pi r squared plus pi r L. So let's keep it like this. Now, as our task is, we will try to get L in terms of R, and then we'll try to get H also in terms of R. So that's the only way. In order to reach to L, in order to reach to H, we have to go through L, because that's what is given. S is given to us. So we have to from R come to L, and from L go to H. So that's what we are going to do. So S equal to pi r squared plus pi r L. You're going to keep the pi r L here, shift is there. S minus pi r squared is pi r L. L is therefore like this. See, we know that we are going to use this relation. H squared is L squared minus R squared. So we obviously want the square. So with that foresight, we get the L squared ready by doing the square. So this is your square expression. Quickly from here, we move to the H, because finally it is H that we require. So from here, we are quickly moving to the height expression. H is L squared minus R squared. This is simple opening up of A minus B the whole squared, A squared minus 2AB plus B squared. With that, you have opened it up and you have kept it ready for our next step. The next step says that H squared is L squared minus R squared. That we know. It happens in the code. So this L squared expression from here, we substitute here, and the R squared is there over there. When you look at R squared is without the denominator, but this one is with the denominator pi squared R squared. So you're equalizing this with the denominator pi squared R squared, and after you equalize it, you're solving. So when you're equalizing it, we observe that there is a pi squared R raised to 4 plus and minus, so they cancel each other, and you get H squared as S squared minus 2s pi R squared over pi squared R squared. Now this we have, now since you have H in terms of R, we are ready to go to the volume. So we'll go to the volume. Volume is pi over 3 R squared H. But please note, what you have got is H squared. So if you have to get H, there will be a root coming. And generally we don't take root. Wherever in expressions where the root is there, you just square the function and go to the square function. The square function will behave exactly the same as the function as far as derivatives are concerned. So we go for the square, keeping in the fact that H is going to be a square root. Since we don't want the square root, we square it. So we are getting B squared as pi squared over 9 R raised to 4 and H squared. H squared expression you have. Substitute that. That is S squared minus 2s pi R squared over pi squared R squared. The pi squared cancels, and the R squared with this cancels. As a result, you're left with 1 over 9 S squared R squared minus 2s pi R raised to 4. There's a square here, so that way. Now this is the concluding touches. We'll go there. We take the first derivative, that is 1 over 9 2s squared R, and here it is 8s pi R raised to 3. We also take the second derivative, d squared b squared by dr squared, that is 1 over 9 2s squared minus 24 s pi r squared by taking the derivative of r cube. Now we'll find the critical point. So dv squared by dr, we are getting it as 0. I mean, that's how we do the critical point. So it's like 2s squared r minus 8s pi r cube equal to 0. We are trying to work it out, and it comes to we solve the s, keep the s on one side, all other terms on the other side, you'll get s as 4 pi r squared. That means r is root s over 4 pi. We'll try to check that value at d squared v over d or squared. You get the value as negative, so we say that maxima occurs. So one of the task is over. The other task is to show that semi-vertical angle is 1 over root 3. Yeah, they say 1 over 3. You have to show that. Sine alpha is 1 over 3. You have to show. Now, sine alpha from the figure, it's very clear. It's r over l. Now, whenever you get this tan alpha or sine alpha, your task is either r in terms of l or l in terms of r, not both. Okay, so even in the previous question, we converted one in terms of the other so that it cancels. So L is a better option. Why? Because many things in terms of L we know. So what we're going to do is, that's what is being shown here. Look at this. L is S minus pi r squared over pi r, but we know S. S we know now, it's 4 pi r squared. So let's substitute S as 4 pi r squared minus pi r squared. So that's 3 pi r squared over pi r. So L works as 3r. That 3r we will substitute here. L is 3r. When we get the critical point, at the critical point, we know that L is 3r. So when we substitute it, that can cancel each other and you're left with 1 over 3. So sine alpha is 1 over 3. And alpha is sine inverse of 1 over 3 as per what they have asked us to prove. So that's all about this problem, where we first show that the volume is maximum, and then whatever that they ask us, we show that also. So that's all for this problem, and it's a very tricky and good problem with more problems, with more MCQs, actually very tricky MCQs also. We'll be meeting in the next video as usual. Popularize the channel and spread a word. Thank you.